Hey guys, let's go over 2021 AP Chemistry first round question. So at the moment, the day I'm filming, the answer key is not available. So I really didn't get to compare my answers for the answer key, but so I'll try my best to go over the questions and explain that if necessary for your test tomorrow. So let's start with number one. Number one, the question is, it seems like there's an acid, which is methanoic acid dissociation. And I think the first question is relatively simple, where it's asking, write the Ka expression for the methanoic acid as it dissociates. So as we know from the acid dissociation, Ka is equal to a concentration of H3O plus times the concentration of HCOO minus divided by concentration of the acid, which is methanoic acid, right? And that becomes, guys, the expression for Ka, which will be a very simple 1 point for the first FRQ question. So, and part B, pretty standard acid-base question, right? So it's asking pH of a 0.25 molar solution of methanoic acid. So, I think this question requires what we call the ICE table or the RICE table, depends on what you want to call this. So first thing first, I'm going to write the equation, which is the acid HCOOH plus H2O turning into H3O plus plus HCOO minus. That's a reaction, guys. I'm not going to write the aqueous or liquid. I mean, that's pretty standard, I believe. So, so you can call this initial change equilibrium, okay, concentration perspective, right? And then, sometimes they call R, that's like the reaction, but again, I was taught using ICE table, not RICE table, so whichever one that suits you guys, okay? So initial concentration is given as 0.25 molar concentration for the acid, okay? So H2O is a liquid, so there's no concentration value, and H2O does not involve the K expression as well, so which means we want to include the H2O. It's only there for the reaction perspective, but it's not going to be calculated in any kind of calculation there. So it means 0 molar concentration for H3O plus and 0 molar for the products, as you can tell. And now, if we know that, guys, at the moment right now, if that's what we have, at the moment, at initial perspective, Q is less than K value, right? So again, we know that, guys, when the Q is less than K value, what happens, guys? The reaction will proceed forward, okay, until what? When Q becomes equal to K value. So the expectation is, we know that some of the acid will be dissociating, which is minus X here, and this will be plus X and plus X, which is the product will get created, right? So now at the end of the day, at equilibrium, we have this concentration of H3O plus, which is what we need for the concentration or the pH, right? At the conjugate base, the concentration is X and X. And the question really kind of comes around for the concentration of the remaining acid, okay, which hasn't been dissociated. That usually is a question. So, as you guys all know, AP chemistry, you can kind of make an assumption of, so X is a really small value compared, because K value is really small. K value they provided as 10 to the power of -4. So it's a really small value, and the concentration relatively large compared to the K value. You can kind of assume that what? The concentration really hasn't changed. So you can kind of say here, the concentration is 0.25 minus X. That is the concentration, but that's what? That's very, very close to 0.25. You can make this assumption for the weak acids. So my recommendation is, if you know the value of X, some questions, right? Like they give you the X value, okay? If you know it, subtract it. But questions like this, where you have to calculate how much of the acid is associated, then you can kind of assume that concentration hasn't changed for the weak acid. So this is a valid you can do. And again, some teachers teach it a little differently, but I recommend you to write that you write 0.25 minus X, but that's going to be very close to 0.25 because it's a weak acid. You might want to make a little statement there as well. Okay, that's my recommendation. Now, since we need the X value, because X represents the concentration of the hydronium ion, which is H3O plus, and taking a negative log of this value X will get the pH, right? So you calculate this, guys, so you got to put these values into the K expression, right? So if you do so, Ka value is equal to 1.8 times 10 to the power of -4, which is equal to x product, which is x squared, x and x, right? X times x divided by 0.25 molar concentration. So now, resolve this, get the value of x. I got the value of x as equal to 0.0067 molar concentration, okay? And then you take a negative log of this number, I got the pH is equal to 2.17. That will be the answer they're looking for part B. Any questions? You can leave that, send me an email, or send me an email, or send any comments, guys, with the email. And part C, okay, let's erase this. Let's go to part C. Part C is asking, in the box below, complete the Lewis dot diagram for the methanoic acids. Show all the bonding and non-bonding valence of electrons. So in these questions, we've seen it on practice questions as well for the previous year's FR2 questions, for response questions. So pretty standard, right? So from what I can tell, there's a carbon here, there's hydrogen there, oxygen here, OH. So this is what we call, guys, like whenever you see COOH, okay. So that's a very standard organic acid, right? So typically you'll see, carbon makes 4 bonds also as well. So hydrogen only makes 1 bond, so that's pretty obvious. And like this is pretty obvious also as well. Okay, so now carbon makes 4 bonds. Okay, so so that's already 1 there, and there's only 2 other ones in carbon. Typically they do not have lone pair of electrons. Okay, so typically, guys, what stuff you'll see is double bond here. Okay, with 2 lone pairs on the oxygen and what? A single bond between the carbon and oxygen, and the oxygen will have 2 lone pair of electrons. And that will give you a full point for part C, okay, drawing the Lewis dot of the methanoic acid. Very standard question. Okay, so now you go back and check if everything has a 10 at least. Okay, so hydrogen, they do not have the P sublevels, which means they only have the S, which means this is a standard, only 1 bond for hydrogen. That's fine. And carbon, it has 4 bonds, 1, 2, 3, 4 covalent bonds. It's every time carbon will have 4 bonds there, and oxygen have 2 lone pairs and bonds, so it's an octet rule. And again, I'm not going to get into the bond orders, but the bond order will be, if you look at oxygen, so they're pretty happy because of the formal charges and such. So I think this is the correct drawing. That's going to get easy 1 point if you've done some practice problems. And let's go to, guys, part D. So personally, I think part D is the hardest question of the FR2 for number 1, I think. So I think a lot of students probably, I'm not sure, maybe they're, have some trouble, I think, being able to answer the second part of D, I think. So let's take a look. So the question is asking, A is relatively simple. Write the balanced net ionic equation for the reaction occurs when H2 and NH2 is combined with the acid. So the equation goes, guys, okay? So this is an acid and base reaction, by the way. So this reacting with the acid, turning into, so basically what will happen is, acid will give off an H+, so base will take it. So this is actually a bronze acid base reaction. So this will turn into H2 and H3 plus HCOO minus. Okay, so, and also for this, you might have to put aqueous, okay, aqueous solution, right? So aqueous. That is the balanced equation for part D1. All right, this is actually D. This is the first part, okay, which is this is what they're asking, a balanced net ion equation, okay. But now the second part is asking, so it seems like same amount, 50 milliliter sample of the base, same concentration, and as the acid, so which means there's an equal amount of these two available, okay, or available to react. And the question is asking, the resulting solution acidic, base, or neutral? Justify your answer. So if you put an equal amount of the base and the acid, okay, then the question is asking, okay, so would the resulting solution be acidic or basic. So I think the first thing that you would have to assume is, okay, so when these two react, what is in the reaction? What's left, in the flask? What's left in the solution? That's something to kind of ask yourself first, okay? So did everything convert into the products, or some of these remain? That's some of the questions you have to ask yourself when you're trying to solve this question, right? So I think, so basically you would have to understand how far the reaction went, okay? So basically if you kind of write the equation for the base reaction, acid reaction, and then try to see if you come up with this equation, try to get the K value, okay? The degree of the reaction, how far it wants the product, depends on what? The K value. So I try to get the K value for this reaction and actually how much the reaction actually proceeded. So if you look at this, so H2 and then H2 plus H2O turning into H2 and then H3 plus OH minus. And this one has a KD value, as we know. Okay, KD value is provided to you, okay, for the KD value for this base. And then I'm going to write the equation, guys, for this guy. So we have a HCOOH, okay, plus H2O turning into H3O plus plus HCOO minus, and it's Ka value that provided the question. Okay, so now if you add these two reactions, right, can you get this, or is there something missing? Is something that you can ask yourself. Okay, if you add these two, okay, it seems like, okay, so this is there, these are there, but then those products, right, so these are present, so it seems like you just add them, but the problem is what, guys? H2O and OH minus and H3O plus, they cannot, they're not going to go away. So you might have to add water in the mix here. So I'm going to write the equation, guys, where H3O plus OH minus turning into H2O. Okay, so, or we can say 2H2O here. So now by adding this, now you can say, look, H2O is going to cancel out, and then OH minus H2O plus is going to cancel out. Okay, so then, yeah, if you actually add this reaction, then you're going to get this. So now, what's the K value for this is a question to ask yourself, right? So this is what, guys? This is actually a reverse reaction of what? Auto-ionization of water. So it becomes what? The K value becomes 1 over KW. Okay, and that's, so if you add all three reactions, you're going to get this, and you can somewhat estimate or get the K value for this reaction. So the KEQ for this reaction based on the calculations. So KD they provided to you, and KA they provided to you as well, and KW is 10 to the power of negative 14, right? So because of the 1 over KW value, the KEQ becomes 2.34 times 10 to the power of 4. So the K value, this is a big number, okay? As you can tell, guys, K value being big, which means what? Probably the reaction went to completion. The reaction went to completion. So which means because we have an equal amount of this and this, which means everything probably have converted into the product because large K value. So now, if everything converts to these two, then should be the case B7. Let's find out, right? So as we know, so these two guys, okay, something that we know from chemistry chapter at AP chemistry acid-base chapter is what? They can go under something we call hydrolysis reaction, which means they can what? Try to act as acid or base and try to react with water. If so, what happens, guys? So I'm going to write the reaction here, guys. H2 and then H3 plus in water. Because we create them, guys, yeah, which means they're in water. This can potentially turn into what, guys? H3O plus, H3 plus and H2, and then H2. So this can be a reaction in what? It can act as an acid, right? And now, the conjugate base of the acid, it can act as a base. Meaning, guys, if you look at it, guys, HCOO minus in water, H2O, can turn into what, guys? Turn into HCOOH plus OH minus, I'm sorry. This can happen. So for AP Chem perspective, okay, whichever one that occurs at a greater degree, okay, will be the one you have to look at, right? It's based on the K value. So if you look at these, if you look at the K value for this, you gotta get the KA for this, you gotta get the KB value for this. So according to this, guys, it seems like, okay, this one has a greater Ka value compared to Kb value for the base. Okay, based on, so yeah, which means because it's back to guys, what? This is a stronger acid compared to what? You know, compared to this base. This is a weaker base, right? So as we know, guys, the conjugates, if the acid is stronger, the conjugates are weaker, okay, as we know. So that's the logic you have to apply, guys, and they give the K value. So Ka value for this is a greater value than Kb for this base. So which means this will be producing greater amount of H3O plus, and hence what? The solution will be slightly more acidic because it produces more hydronium ion compared to the hydroxide from the bottom reaction. So that's probably the reason why I think for the answer for D2, which is the hardest question of the entire thing, I think should be acidic because this one has a greater K value. Let's go to part E. So they're providing a different reaction here, and the question is asking for E. The question is asking, is a reaction redox reaction or not? So let's take a look at the reaction for this. The reaction is the methanoic acid is turning into H2 gas and CO2 gas. So you would have to understand that if they're asking whether the reaction is a redox or not, you would have to understand that what? You have to be able to calculate each individual reactant's elements, their oxidation state, the charges, right? Let's find that out. So if you look at it, guys, as a product, these are easier, right? So the charge, this element, right? So charge of hydrogen is 0, and oxygen is typically -2, and charge of carbon is +4. So these are the charges, right, for the product. So if any of these values are different on the reactant side, this is a redox. So if you look at this, hydrogen here is +1, so there we go. I mean, you can tell this is a redox. Hydrogen here is also +1 here as well. Oxygen is -2. Okay, so then what with the charge of carbon? The whole thing, it doesn't have any charge at all. So if you add up all these oxidation states for the elements within the compound, you have to add up to 0 because that's 0. There's no charge for the compound overall. So if you look at it, guys, the charge of carbon is what? +2. So hydrogen goes from +1 to 0. Carbon goes from +2 to +4. There we go. There's an exchange of electrons. Hydrogen is gaining electron. Carbon is losing. So if there's a transfer of electrons within, the elements or compounds, what happens? This is what we call a redox reaction. Let's go to part F. Question is asking, the reaction above occurs in the rigid 4.3 liter vessel and 25 degrees Celsius. Total pressure is monitored. And then the vessel originally did not contain any gas. Calculate number of moles of CO2 produced in the reaction. So they gave the pressure, and they gave the volume, they gave the temperature value. So they're asking for number of moles of CO2. Can you get this? So it seems like the pressure reaches 24 atm based on the graph they provided. So, and they gave you a lot of information on this one. So my recommendation of this question part F is first the question is what? Yeah, write the P-valent equation, the ideal gas law. So they're looking for the moles. Do we have all the information to get this? Do you have pressure? Do you have volume? Do you have temperature? I think you have all. So the pressure becomes 24 from the graph, 24 atm. And volume is given as what the question states, 4.3 liters, is equal to number of moles, which is what we're trying to find out, I'm going to divide by the RT. So R value, as we know, you can get that from the first page here. I think I'm going to use 0.0821 as the value of R. And temperature value, I think I'm going to use 25 degrees Celsius, 298 Kelvin. Just get it Kelvin here, guys. So if you solve this in a calculator, you probably get your number of moles. So my answer, regardless, guys, is I got the answer as 4.2 moles of CO2 is what I got. Okay. RG, the question is asking, after reaction has proceeded for several minutes, does the amount of catalyst increase, decrease, or remain the same? So as you guys know from AP Chem, catalyst, what do? The main role of catalyst is to provide a different pathway for a reaction with the lower energy of activation for the reactions to proceed with a greater speed. So, and some of the things you probably heard a lot, even the AP Bio, these catalysts themselves, okay, do not get consumed from the reaction. So they can react. So some of the, so by being able to give them a different path for the reaction, they themselves might react. But at the end of the reaction, they come back out. Which means if catalyst goes in, they have to be not get consumed in a reaction. So the question is asking, okay, so as the reaction proceeds, okay, the amount of catalysts go up or down, those remain the same. So this is a very standard question that catalysts are not gonna get consumed in a reaction. So yeah, it should not change, it should remain the same because catalyst, it doesn't get consumed in a reaction. They're not reactants, they're not products, okay? That's number one for the FRQ for 2021.